So 3.3, we're doing reflections and translations. We have already gone over a lot of this stuff. So today is taking the reflections and the translations and putting them into a coordinate plane. So you're going to have actual ordered pairs now for your stuff. Okay, we've done a lot of this already though. So reflections. A reflection is a transformation across a line. You're called the line of reflection. So that the line of reflection is the perpendicular bisector of each segment, joining each point at its image. So the pre-image and the image must be equidistant from the line of reflection. Okay, so if you look at that picture on the right, we have point A. We reflect it over the line to get A prime. The distance from A to the line has to be the same from A prime to the line. So they have to be equidistant from the line of reflection. Okay? All right, recall that a reflection is a transformation that moves a figure, the pre-image, by flipping it across a line. The reflected figure is called the image. A reflection is an isometry, so the image is always congruent to the pre-image. That's the stuff we've already talked about. So we have rules. So reflection in the coordinate plane. So yesterday we used the compass and all that. Today we're going to apply rules to the coordinate plane to get our reflection. Whenever we are reflecting across the x-axis, we are going to keep the x the same, and then you are going to change the sign of the y value. Okay, so your rule is how you read this. X comma y transforms to x comma opposite y. Okay, you do have to know your rules by heart. Okay. All right. Whenever we reflect across the y-axis, we are going to do the opposite of x, but keep the y the same. So that states x comma y transforms to opposite of x comma y.
Is it because that's the way that the accordion moves, like x moves left and right? Oh, okay.
Yep. All right. If we reflect over your diagonal, so a positive diagonal, y equals x, then we flip, uh-oh. Stop it. All right, we flip our y and x. So if we start there at point P, we reflect over the diagonal, positive diagonal line, we end up at y comma x. So you flip your x and y. Okay, if we reflect across a negative diagonal, so y equals negative x, then we're going to flip our x and y, and we're also going to do their opposites. So we're going to make them negative. So once again, you have to memorize those rules. All right, let's apply them. Reflect the triangle with these vertices. So first we need to draw the triangle, so take a minute, draw the triangle. I would like nice clean lines. Okay, we are reflecting across the y-axis. So there's our line of reflection, the dotted. And then we need to do it one of two ways. You can use your rule. So x comma y transforms to, what was our y, or what was our rule for over the y-axis? Opposite of x, but keep the y the same. So you can apply your rule and plot your points, or you can keep equidistant, like what we talked about on the front page as well. So z is how far away from this line? 3, so then z prime would have to be equidistant on the other side. It works on the ordered pair too. Z is at 3, 2. You change the sign for x, so that'd be a -3. Y is 2. Exactly the same. So you can do it either way. So that's z prime. Okay, so x is 2 away. So we go 2 away on the other side. You can also do opposite of x is -2, -1. And then y is 4 away. So we're going to go 4 away on the other side. Once again, I would like clean lines. So, kind of looks like a butterfly. Any questions there? Okay, let's get started on the next one. Reflect the rectangle with these vertices over the line x equals 1. This one, x equals 1, does not have a rule. Okay, so there's no rule from the first page for an x equals a number or a y equals a number. So whenever you have that, you have to do equidistant. So if you don't have a rule to apply, you're going to have to use the equidistance property. So let's draw the rectangle. Okay, and I'm going to put a dotted line where my reflection should occur. So where is x equals 1? What kind of line should that be? Vertical, good. Where it crosses x equals 1. So here's my line of reflection. Vertical line across 1 on the x-axis. So since we don't have a rule, remember we said equidistant. So how far is v away from this line? 3. So we got to go 3 on the opposite side. So equidistant over here would be v prime. Does that make sense? Okay, how far away is us? 2. So there's s prime. And then same thing for u and t. So the purple is your image. Do you have any questions so far? All right. Can I move on to number 3? I'm going to take that as a yes. All right, number 3 says reflect the segment. So we did a triangle, a rectangle, now we're going to do a segment. Cross the line y equals negative x. So that's your negative diagonal. What was that? Had a rule. So what was the rule for the negative diagonal? Good. Opposite of y, opposite of x. So that was our rule. Now if we graph our segment, here's R. Here's S. Okay, and then I'm going to make a dotted line for our line of reflection. So that dotted line was our negative diagonal. The negative diagonal should go through the origin and have a slope of -1. So there's our line of reflection. What do you notice? Anybody? Yes, Emily. Goes through one of the points. And what have we learned if one of your points is on the line of reflection? Stays the same. Okay, so the only thing we have to reflect is S, correct? Okay. Since our distance is diagonal here, it's going to be very difficult for us to flip it over diagonally. But you can do it if you want. Okay. I would just stick to the rule on this one. So S's point is 5, 0. So if we plug it into this, that would change it to 0, -5. So that's going to be down here. All right, any questions? Yes. Oh, yeah, sorry. Good catch. Yes, Akash is right. We need to add R prime for the segment. So we still have to do the point labeling. All right, any questions on reflections? Okay. Translations. All right, we've done a lot with translations as well. A translation is a transformation where all the points of a figure are moved the same distance in the same direction along a vector. A translation is an isometry. We already know that. So the image of a translated figure is congruent to the preimage. So we can move 3 different directions. So horizontal translation. Vector form has these little arrows. Okay, so it looks like an ordered pair, but instead of parentheses, it's got kind of like big arrows on the end. Okay, so that's your vector form of it. So whenever we horizontally translate without going up or down, you just do x plus a, and then you keep the y the same. Okay, so a is your transformation. Like, how many did you move? So down here, write that in. So that's your rule. Okay. A vertical translation. So you stay horizontal, so that would be a 0, and then you move up or down with B. So that's going to be y. Actually, it should be a plus or minus. Change this over here to plus or minus for the A, because you can move left or right and you can move up or down. So it needs to be a positive and a negative. And then diagonally, that would be, in general, we shift left or right and up or down. So our full rule will be x plus or minus A and y plus or minus B. All right. Translate each polygon using either the rule or the vector given. Graph the preimage and the image. List the image's vertices. So translate this triangle along the vector 3, -1. So first thing we got to do is graph the triangle. So let's graph the triangle. If I'm ever off on a point up here, please tell me, because it's kind of hard sometimes to see it so close up. Alright. So there's triangle DEF. And then it says along the vector 3, -1. So if we turn that vector into a coordinate rule, that would start with x comma y transforms to x plus 3, since it's a positive 3, and y minus 1, since it's a -1. So what that's telling you to do is take each of your x's and go right 3, and each of your y's and go down 1. So we're translating everything right 3, down 1. Alright, so that's what you're going to do next. So go ahead and do that on the graph. Move all these right 3, down 1. And once you have that drawn, the next step says image vertices. So that means it wants the ordered pairs for D prime, E prime, and F prime. So you have to write down each of those ordered pairs now. So D prime, Alright, do you guys have any questions about the translation? Do I have anything wrong? Can you guys see from further back? My eyes are already starting to go blurry with up here. How close it is. It's good? Okay. Alright, next one. Okay, translate this. Uh-oh. Nope, that's not what I wanted to do. I don't want that page. I want this page. Okay. Translate this segment with endpoints 2, 5, and 0, 2 using this rule. So let's graph the segment 2, 5. This is like a baby segment. This guy's tiny. Okay, and then it wants us to turn the coordinate rule into a vector form. So triangle, what would we put into the triangle order pair? -3, comma what? 3. Good. So that's the coordinate rule in vector form. So we need to shift our vector how? Or shift our segment left 3, up 3. Good. So left 3, up 3. And then it wants the new ordered pairs. any questions? Okie dokie. Number 6, it's got our pre-image and our image drawn for us. It says describe the translation using vector notation and writing the rule. Should have said coordinate rule, but that's fine. So first you need to identify which one's the pre-image and which one's the image.
The bottom one's the pre-image because it doesn't have the sign.
Good. This one's our pre-image because it doesn't have primes. So this is where we start. And this one's image. So we are going from here to there. So how do we move? What did each point do?
7.
Up 7?
Yes, 7.
And
Mine first.
left 3? Everybody agree with that? Okay. So vector form, we said left 3, up 7. And then coordinate rule. There you go. Any questions? Okie dokie. Number 7, without a picture, can you do it? So triangle GHI transforms to triangle G prime, H prime, I prime. The coordinates of GHI are those. The coordinates of G prime, H prime, I prime are those. State the rule, write the vector. So how do we move from the pre-image to the image? What did you do to each of those ordered pairs? Left 2 and 0?
Yeah.
Okay, so how do we write that as a vector?
-2.
0, good. And then coordinate rule, x minus 2, and just y. Very good. So we don't need to add or subtract a 0. We just keep the y the same. All right, last page. Compositions again. So we learned about these yesterday. A composition of transformations is one transformation followed by another. So we got to be able to put them together more than one. All right, a glide reflection. This is a very common composition. So whenever you look at triangle JKL, I gotta sneeze. Sorry. A glide reflection is translating it and then it flips it. So that's what we call a glide reflection. Any questions on that? Okay. All right. The image after each rigid transformation is congruent to the previous image. We know that because they're all isometries. By the transitive property of congruence, the final image will also be congruent to the pre-image, which we also learned about the transitive property before. Any questions about that? All right, so a composition of two isometries is an isometry. So let's do them. Translate triangle PQR along -2, 5, the vector, sorry, -2, 5. Then reflect its image over the x-axis. So first, let's plot the points. whenever we start getting multiple pictures onto one coordinate grid, I will say we've had lots of kids use colored pencils, erasable pens, fun colors, whatever, to show their differences between each one. So if you like that kind of stuff, you are more than welcome to. You can see Miss Winans and I do that because there's all kinds of colors on these notes. All right, so the translation rule here would be x comma y transforms to x minus 2 and y plus 5. So let's translate it first. So we're translating it to where? Yes. We're translating half. What does the rule say?
Down or
Left 2 and
up 1.
up 5. So let's translate it left 2, up 5. Okay, after you translate it, we need to write the ordered pairs, the new vertices. All right, how's that translation look? All right. Now remember, like our compositions yesterday, whenever we did the hexagons and things, you did one transformation, and then you took that one, and then you did the next one. So whenever we do the reflection, we're going to do the reflection with the green triangle, the primes, not the original. Okay? So what's my rule? Because it says reflect over the x-axis. Who remembers the rule from the front page? X opposite of y. Any questions there? Okay. So my x-axis is here. So I'm taking my green and I'm reflecting it over the purple reflection line, the x-axis. And then remember, we use double prime for the second copy. And then the ordered pairs should be super easy because you just apply the rule to these ordered pairs written down. So we keep the x the same, we do the opposite of the y. Keep the x the same, do the opposite of the y. Keep the x the same, opposite of the y. And that should match what you graphed. Alright, so it takes a while to do some of them, but is it difficult? No. Not really. Okay, probably the most difficult thing is just memorizing the rules, to be honest. Any questions for today? Okay, you got some time to work on your homework, and then we're going to start rotations somewhere in next period.
The next